Hello everybody, this is Dr. Thunder. Today I would like to show you how to solve a US high school physics competition question. This is the last question of 2024 F equal MA exam, or question number 25. So we have a yo-yo consists of two massless uniform disks of radius r connected by a thin axle. A thick string is wrapped many times around the axle, so that the end of the string is initially a distance capital R from the axle. Then the end of the string is held in place and the yo-yo is dropped from rest. Assume that energy losses are negligible and that the string has negligible mass and always remain vertical. So between the moment the yo-yo is released and the moment the string completely unwinds, we want to find out which of the following answer, A, B, C, D, or E, is true regarding the yo-yo's acceleration A. So first we assume L is the string's total length. Then at this moment, yo-yo is dropped by a distance of z. So the ratio between L minus z to L is the ratio of this circle, which has a radius of lowercase r, so which the area is pi r square, and then the area of the yo-yo is pi capital R square, that's equal to lowercase r square over capital R square. We define as equation 1. Now let's look at the energy. Because yo-yo is dropped by distance of z, the potential energy is mgz as converted to kinetic energy. First is the translational kinetic energy, which is half m. M is the mass of the yo-yo. Half m v square. V is the translational velocity speed. And then we know that yo-yo is rotating at the same time, so the angular velocity is omega. So the rotational energy will be half I omega square. I is the moment of inertia of the yo-yo. If you can memorize it, for the disk with mass m and radius r, the moment of inertia is half m r square. But if you cannot memorize, we can use the integral method to quickly get it. So here we draw this yo-yo again here. So we take a ring here. The ring has a very small thickness. So assume ring is x from the original point O, and then the thickness dx. So the area of this ring is proportional to the mass. So the moment inertia di will be equal to dm x square, x distance from the origin. So dm is this ring area, which is 2 pi x multiplied by the thickness of dx, or the width dx, over the whole area of the yo-yo, which is pi r square, and then multiplied by the total mass m and x square. Then we simplify to 2m over r square as cube dx. Now we integrate this. So the moment of inertia will be integrate over di, and then we plug di's expression here. So we integrate x is from 0 because initially it's at 0, then it gradually go from 0 to capital R. So we integrate from 0 to R. So this term after integration, it becomes x4 over 4. So then we plug R and 0 into this expression. Eventually we get half m r squared. So now we have this moment inertia. So we know that angular velocity is v over r. So now the equation 2 becomes this. We plug I and omega into equation 2, we get this. And we clean up. Eventually we get v equal to this expression. Now we plug equation 1 here, so it further become square root of 2gz over 1 plus L over 2 L minus z. Now this is a pretty complex expression. To simplify it, we assume that z equal to KL. As we know, z is a distance that yo-yo can drop. In the beginning, z is 0. In the end, when yo-yo is completely unwind, and z is L, so k is between 0 and 1. Now we plug this expression into v, so we get this. Now we look at what's inside the square root, or k over 1 plus 1 over 2 1 minus k here. So as this is pretty easy to calculate, maybe we can calculate within 1 minute. So when k is 0, this expression is 0. When k is 1, this expression is also 0. And then we can calculate 0.1 all the way to 0.9. And then we quickly plot it. So we can get this behavior of v versus z over L. As we can see, when z over L is about 0.6, v reach the maximum value. And then v begin to go down until at last at some moment v is equal to 0. So from here to here, or the acceleration is greater than 0. At this moment, acceleration is 0, and then at this moment, acceleration is smaller than 0. If you look at this figure here, when yo-yo is going down, initially a is greater than 0, means it's accelerating. But at some moment, v begin to decrease. So acceleration is actually pointing upward. So this corresponds to answer E, and all other answers from A to D are not the right answer. So thank you for viewing. If you like my video, please comment, like and subscribe.